of cosines today. The law of cosines can be used when you're given two sides and an included angle, or when you know all three sides of the triangle. And you can use this in order to solve it. So law of cosines looks like this. It says a squared equals b squared plus c squared minus 2bc cosine of angle A. Now this is actually just one version of the law of cosines. You could use this with any of the three sides over here. The main thing is if you have b there instead, then over at the end of this thing you would have cosine of b instead of cosine of a. And then in the places where we've got b squared and c squared instead of b squared, we'd have a squared. And here instead of b, we'd have a. So I could do that with c also, of course. We'd have to have angle C over here on the far right, and then the values that are here would have to be A and B. But anyhow, so we can use law of cosines to find any side of the triangle. We could also use this to find any angle of the triangle. So let's see how that works. We're going to start off with, one more note there. I mentioned this already, but we can only use it if we have all three sides or if we have a side angle side. So the angle has to be between the two known sides. Okay, so here's our given information. We've got angle A is 25 degrees, angle B is, side B is 9, and side C is 12. So just to get an idea, I have a little diagram to work with here. I'll say angle A is over here. And so we said that's 25 degrees. Side across from it is little a. That's the one that I don't know yet. We'll say this one over here is side B. So this is 9. So that means this one over here is angle B. And angle C would be up on top. And then side C would be on the bottom. So this is little c is 12. All right, so with this one, with the given information that I have here, I only know one angle, and I don't know all three sides yet, so I cannot find either of the other angles. The first bit of information I can find is A. And my law of cosines, the one that I had originally, was set up just for that. So I'd have a squared is equal to, and then I need b squared plus c squared minus 2bc, and then cosine of the included angle, which was 25 degrees. Okay, so when I put this in my calculator, I would have to either start off with a square root, or I could put this whole thing, this whole original thing in parentheses, like this, when I put it in the calculator. And then I could raise it to the 1/2 power, which is the same thing as taking a square root. So either way, I put that in my calculator, and I get approximately 5.407. Okay, so now I have a value for the third side of the triangle. It is an approximation, and unfortunately, in order to find everything else on this triangle, we are actually going to have to use that approximation. We don't have a choice. So let's pick which angle we want to find next. I think maybe we'll go for angle B next. So to find angle B, when I'm setting up my law of cosines, I'm going to scoot down just a little bit here so I have more space. I would have to have b squared over here, which would mean that over here after the cosine, I would have to have angle B. So when I'm filling in the rest of this stuff here, I've got a plus there and a minus there and a 2. Since I've got side B already over there, that means in the blanks, in the rest of the blanks, I would have to have A and C. So this is a squared and c squared, and this is AC. So I'm going to go ahead and fill those in, and then we'll see how to solve for angle B. So side B is 9, so I'll fill that in. 9 squared equals Side A is 5.407. That one's my approximation. That didn't come out real nice, and I think I'll have problems if I can't read my writing there. Since I am using an approximation in here, I need to say approximately equal to already. I've got c squared, so that's 12 squared, and minus 2 times a times c, and then cosine of angle B. All right, so this time my unknown quantity is that cosine of B. So what I'm going to do is I'm going to rearrange some things. First of all, you need to see all of this here as a single unit. That's one term for now. So what we're going to do, since it says minus that, is I'm going to add this whole thing to the other side of the equation, and then I'm going to subtract 9 squared from both sides of the equation. So essentially, I'm just kind of changing these two things that I underlined in pink there. I'm going to change their location. So that's going to make this say 2 times 5.407 times 12 cosine of B, approximately equal to, and then I had everything that was already on the right, so 5.407 squared plus 12 squared, and then minus 9 squared. All right, so now to solve for B, I'm going to kind of do everything all at once here. We'll talk about the order and I'll show it while I'm doing it, but I'm not going to write each of the steps because it's just taking way too long to write on this screen here. Okay, the first thing I would need to do to solve for B would be to divide both sides by these things that are being multiplied by cosine of B. So that would give me everything that's on the right already. So 5.407 squared plus 12 squared minus 9 squared divided by 2 times 5.407 times 12. And then finally, I would need to get rid of the cosine because I still had cosine of B over there, if you recall. So to undo the cosine, I would use the inverse cosine. So I would have inverse cosine then of this entire thing. Okay, now I'm finally ready to put that in the calculator. So I'll go ahead and pop that in. And I get 44.702 degrees. All right, so now I have angle B. I'm going to go ahead and put that up on my diagram. That's 44.702 degrees. Okay, now I could do the same thing again to find angle C, but I think for sake of brevity here and because we're working with inferior tools, the scientific calculators rather than our Inspire graphing calculators, I think to find angle C, I just want to use the fact that the sum of the three angles of a triangle is 180 degrees. So I would say then angle C is approximately 180 minus the sum of the two that I have now. And again, I would put that in my calculator and I get 110 degrees, sorry, 110.298 degrees. And so that would be my final value. So my solutions for this triangle, let me get another color that'll stand out a little bit better. I had my value for side A, I had my angle B, and then I had angle C. So three answers here. All right, now you try the next couple of questions on the Google form.